So in the last video we have learned about the Newland's octaves, and now next topic is his own thing, that is octave. From H the eighth element is fluorine. We can see the similarities in those two elements, first and eighth. So on the page 17, figure 2.2, you can check there are so many in the sense 2 or 3 sets of 8 elements which can give you the idea of octaves. So as per science, the things which are perfect are accepted. And now Newland's octave theory was put forth for the discussion, and there were so many limitations found. So question number, I don't know the question number you write. Write the limitations of Newland's octaves. Page number 17, last but one paragraph. It says, many limitations were found in Newland's octaves. Many limitations were found in the Newland's octaves. This law was found to be applicable only up to calcium. This law was applicable up to calcium. Newland's fitted all the known elements in the table of 7 into 8. That is 56 boxes. He made 56 boxes, and in those Newland placed 2 elements in each in some boxes to accommodate all the known elements in the table. He had put 7 8s, 56 boxes, but there were some extra elements. He put, see here, cobalt and nickel are kept in one box. So that is wrong. This was limitation of Newland. Next is element in the table. For example, cobalt and nickel. Cesium and lanthanum are also, I have not shown here, but cesium and lanthanum both were in the same box. And Fe having similarity with cobalt and nickel are away from them along with the non-metals oxygen and sulfur under the note T. So there are abnormalities. Fe should be with metals. It is with non-metals. So this is also anomaly. Abnormality, anomaly and limitations all have same meaning. Newland's octaves did not have provision to accommodate the newly discovered elements. After those 56 elements, new elements were discovered. He could not accommodate those elements in the boxes. The properties of new element discovered later on did not fit in the Newland's law of octave. After calcium, the elements did not obey the law of octave. So these were the limitations of Newland's octave. This question will come for 2 marks. Write limitations of Newland's octave. So we have learned the triads octaves of Demerits and Newland. Now the great jump was taken by a Russian scientist Dmitri Mendeleev In 1863, only 63 elements were known to mankind. So he arranged, first time he arranged, instead of 3, instead of 8, he arranged all known elements in the increasing order of their atomic masses. Their increasing order of their atomic masses. Then he has done a great job. He is called the father of modern periodic table. And in the periodic table, element 101, element with atomic number 101 is given the name Mendeleevium. It is in the respect of Mendeleev. So we are starting Mendeleev's periodic table. He took a great jump, really great jump, and he was the first man. He done around 85 to 90% work of the classification of elements. So great jump he has taken in 1863. So what he done? The Russian scientist Dmitri Mendeleev developed the periodic table of elements during the period of 1869 to 1872 AD. Mendeleev periodic table is the most important step in the classification of elements. Just I told you, he has taken a great jump. Mendeleev considered the fundamental property of elements, namely the atomic mass, and arranged 63 elements known at that time in an increasing order of their atomic masses. Then he transformed this into a periodic table of elements in accordance with the physical and chemical properties of these elements. 1 to 63. He arranged in an increasing order of their atomic masses. On page number 18, you can see the Mendeleev's periodic table. He has given 12 rows, 1 to 12 rows, and 12 rows, those are called periods, and 1, 2, 3, 4, 5, 6, 7, 8 columns. 8 columns and 12 periods, rows. They are called rows and columns. So it started with hydrogen and ended with the uranium, known at that time. He studied the properties of elements, how they react with hydrogen and oxygen. He studied the elements' tendency to react with hydrogen and oxygen. So the salts were called hydride and oxides. So he studied the reactions of those elements with oxygen and hydrogen. So he named hydrides and oxides. Mendeleev organized the periodic table on the basis of chemical and physical properties of elements. These were the molecular formulae of hydrides and oxides of the element, melting point, boiling point, and densities of the elements and their hydrides and oxides. Just I told you, he studied the tendency of that particular element to react with hydrogen and oxygen, forming hydride and oxide. This is main property. And then the appearance, melting point, boiling point, and densities he took into consideration and arranged in a table. Mendeleev found that the elements with similar physical and chemical properties repeat after a definite interval. In this table, he is shown कि after certain intervals the elements having same properties are repeating. So it is called periodic function. Periodic, the meaning of periodic is, suppose today is Monday, and after exact 7 days you will get again Monday. After 7 days you will get again Monday. So after 1 year your birthday will reappear. After 12 months Diwali will reappear. After say seasons, season of mangoes will repeat. So these are periodic function. After certain period, not time, it may be different thing. After certain gap, the same thing repeats. So he called it a periodic function. Periodic function means one thing which is repeating again and again. So what he said, Mendeleev found that the elements with similar physical and chemical properties repeat after a definite interval. On the basis of this finding, Mendeleev stated the following periodic law. Properties of Mendeleev's periodic law says, properties of elements are periodic function of their atomic masses. So here it ends the Mendeleev's periodic table's note. Mendeleev's periodic table. Nobody is going to tell you to draw the Mendeleev's periodic table. No one. So description is there. He studied the oxides and hydrides of the property of the elements. Then density is melting point, boiling point, and he arranged the known elements in increasing order of their atomic masses, and he found that the properties are repeating after certain interval of atomic masses. So he stated the law. The properties of an element are periodic function of their atomic masses. So after certain atomic mass, that property again repeats, or properties may repeat. So he said his own periodic law. Properties of element are periodic functions of their atomic masses. Bracket complete, answer complete. There will be a smaller question. State periodic law of Mendeleev. Yeah, Mendeleev's periodic law. State Mendeleev's periodic law. That will be for a smaller mark. It's question. Whatever new things are developed in science, they should pass some test of reality. So, Mendeleev's periodic table was put in the discussion, and first topic was what are merits of Mendeleev's periodic table. Merits means plus points. So, question page number 19. There is a question. Write merits of Mendeleev's periodic table. Very important question. So, while applying the law that the properties of elements are periodic function of their atomic masses to all known elements, Mendeleev arranged the elements with the thought that information available till then was not final but it could change. He thought for the future. The new things will be discovered, new elements will be discovered. He thought like that, and as a result, this Mendeleev's periodic table demonstrates the following merits. You don't have to write these ornamental sentences. Just write following are the merits of Mendeleev's periodic table. Just write following are the merits of Mendeleev's periodic table. First is atomic masses of some elements were corrected. Previously, the atomic masses of some elements were taken, say X, so they were changed to Y. How? Because of the place of the Mendeleev's periodic table. Place of that element in the Mendeleev's periodic table. Atomic masses of some elements were revised so as to give them proper place in the periodic table in accordance with their properties. Scientists were taking wrong atomic masses of certain elements. They were corrected because of Mendeleev's periodic table. Mendeleev's periodic table. This was the first merit. So what happened? For example, previously determined atomic mass of beryllium was 14.09 was changed to correct value 9.4. The beryllium's atomic mass, previously it was taken as 14.09, but actually it was 9.4, and beryllium was placed before boron. This was the first merit. This is one example they have given. There may be other examples also. Second is, Mendeleev predicted some elements will be discovered in future and kept vacant places for them. He said 63 elements are not the end of the world. 63 elements is not the end of the world. New elements will be discovered in future. So I mean not me, it is Mendeleev. He had kept some vacant places in his periodic table. So let us see what he said, what he has done. Merit number 2, Mendeleev kept vacant places in the periodic table of elements not discovered till then. Great fellow. He said, I am keeping some empty spaces in my table. These elements will be discovered in future, and their properties also he had predicted their properties also. How? Three of these unknown elements were given the names Eka boron, Eka aluminium, and Eka silicon. Eka means next, one place ahead or backside. Eka. These three unknown elements were given the name Eka boron, Eka aluminium, and Eka silicon. He had given the name Eka aluminium, Eka boron, and Eka silicon. From the known neighbors, and their atomic masses were indicated as 44, 68, and 72. So see, only by thinking and mathematics, he had predicted there are three elements which will be discovered or invented in the future, and their atomic masses will be 44, 68, and 72 respectively. Not only this, but their properties were also predicted. He had predicted the properties. Later on, these elements were discovered and named as Canadium Sc, Gallium Ga, and Germanium Ga respectively. The properties of these elements matched well with those predicted by Mendeleev. We are in the second merit of Mendeleev's periodic table. He had predicted these type of elements will be discovered in the future and their properties will be like this. So really they were found and the properties were exactly same according to his prediction. Mendeleev predicted by Mendeleev. Mendeleev was really saw the future. He saw the future. And last point of this point is, due to this success, all were convinced about the importance of Mendeleev's periodic table. And this method of classification of elements was accepted immediately. So as per his predictions, the elements were found in the near future, and Mendeleev's attempt was accepted by science immediately. Third merit, there was no place reserved for noble gases in the original periodic table. He had not kept a place in that table, but noble gases were discovered afterward. Without disturbing the table, at the last of the table, they put one column. They put one column, and in that column, noble gases were arranged with ease. Very easily they were arranged there. There was no place reserved for the noble gases in the Mendeleev's original periodic table. However, when noble gases such as helium, neon, and argon were discovered towards the end of the 19th century, Mendeleev created a zero group without disturbing the original periodic table, in which noble gases were fitted very well. So, in the third point, we have seen that noble gases were not discovered till then, but afterward they discovered the noble gases. So, where to put them? That was not a question. He arranged a separate column for them at the end of the periodic table, and all noble gases were arranged in that column, and the question was solved. This was third merit of periodic table of Mendeleev. So Mendeleev shown great achievement and made great achievement. He has taken great leap in the science because of his prediction and his empty spaces, other things very well. After seeing the merits of Mendeleev's periodic table, the negative side of Mendeleev's periodic table came forward, and those are called demerits of Mendeleev's periodic table. What were they? Here are they. Ambiguity in cobalt and nickel's properties and places. Cobalt and nickel were having round figure atomic numbers, and where to adjust them was the first demerit. Demerits mean drawbacks. So cobalt and nickel arrangement was not clear in Mendeleev's periodic table. Second is isotopes. Isotopes means elements having same atomic number but different atomic masses. Elements with same atomic number and different atomic masses. Those were not able to adjust themselves in Mendeleev's periodic table, or where we needed the explanation of isotopes. Mendeleev's periodic table was not able to explain them. Isotopes were discovered after a lot of time of Mendeleev's periodic table, and it is related with Mendeleev's periodic table. What to do with isotopes? By applying the law, periodic function of their atomic masses. So isotopes were not explained by using law of Mendeleev. Next is atomic masses did not show uniform rise. The atomic masses, he arranged the elements in the increasing order of atomic masses. These atomic masses did not show uniform rise 1, 2, 3, 4, 5, 6. This type of increase they did not show. And the last one is hydrogen created a problem. hydrogen was showing properties of halogens. Halogens means chlorine, fluorine, bromine and iodine. They are highly reactive. They are highly reactive. Hydrogen is also highly reactive. So hydrogen was showing properties like halogens also, like chlorine family, and it was showing properties like sodium also. It was showing properties like alkali metals also. So where to put hydrogen? In halogen family or in alkali family? That was the question. So let us see the demerits of Mendeleev's periodic table. One more question, very important for the exam. Write demerits of Mendeleev's periodic table. You can check old papers. You will get either of these two questions, merit or demerit. The whole number atomic mass of elements cobalt and nickel is same. Therefore, there was ambiguity. Ambiguity means not clear, non-clarity. The idea was not clear. Ambiguity means idea was not clear. Where to put them, where to place them. Regarding their sequence in the Mendeleev's periodic table. So, I explained you cobalt and nickel created a problem. Isotopes were discovered long time after Mendeleev's put forth the periodic table. As isotopes have the same chemical properties but different atomic masses, the challenge was posed in placing them in Mendeleev's periodic table. Placing in the sense explaining. Isotope explanation was not possible with Mendeleev's periodic law. That was second drawback. Third is, when elements were arranged in the increasing order of atomic masses, the rise in atomic mass does not appear to be uniform. The rise of atomic masses was not uniform. So that was third demerit. And fourth is position of hydrogen. Hydrogen shows similarity with halogen, that is seventh group. At this place, it is not possible to explain you seventh group and all these things. Just remember, hydrogen was showing the properties of halogens, means highly reactive material, chlorine, bromine and iodine. At the same time, it was showing the properties of alkali metals like sodium, aluminum, like that. So where to put it? That was the question. So fourth was, position of hydrogen was not decided by Mendeleev's periodic law. On considering the above properties, it can be decided whether what is the correct position of hydrogen in the group of alkali metals or in the halogen group. So these were the demerits of 4 demerits. Ambiguity, not clarity in the position of cobalt and nickel. Isotopes did not find any explanation. Atomic masses were not showing the uniform rise, and hydrogen was behaving like a member of double family. So where to put it? So these were the demerits of Mendeleev's periodic table. It will give you good marks if you make merits and demerits both. Very nicely you study these topics, and hereafter the efforts are ended, because Henry Moseley first time put forth the theory that atomic mass is not a fundamental property of an element. Atomic mass is not a fundamental property of an element. He said atomic number. Atomic mass means actual mass, weight. Atomic number means number of electrons or protons present in an atom. So Henry Moseley put forth his theory, forget atomic mass, atomic number is a fundamental property of a element. Great. all anomalies were disappeared. All anomalies means drawbacks, were disappeared from Mendeleev's periodic table. Henry Moseley said that atomic number is a fundamental property of an element. Don't take atomic masses, take fundamental property, atomic number. Atomic masses means actual masses of those atoms, but atomic number means the number of electrons or protons present in an atom. So Henry Moseley came forward with a theory which helped Mendeleev's periodic table to get the modern periodic table. The modern periodic table is a combined effect of the Dobereiner, Newland, Mendeleev plus the high ending efforts of the Henry Moseley. Henry Moseley said atomic number is a fundamental property of an element, not the atomic masses. So all combined efforts came together to give rise to the modern periodic table. Modern periodic table has very less changes since it was invented. We will see modern periodic table. We will see modern periodic table with modern periodic law.